Hello guys. So today I have something very special for you because so many times I get this individual query how to solve these questions related to astigmatism. So let's clear them once for all. So we take an example and with the help of that we'll try to clear the concepts regarding these astigmatism numericals. Which of the following is an example of compound myopic against the rule astigmatism? So in one line they have asked so many things. Can you see they have try to ask whether you know what is compound astigmatism, what is myopic astigmatism, what is against the rule astigmatism, and what is actually astigmatism. So let's try to clear it step by step. First of all, we will start with the astigmatism. What is actually astigmatism? Astigmatism simply means when I have the different power in the two meridians. This is as simple as that. If I have different power in at least two meridians, then that is called as astigmatism. For example, if I take this, so I have two meridians here. One is the horizontal meridian and one is your vertical meridian. So if I have the different power, I can have +3 +5. Yes, it is astigmatism. Similarly, if I take another example, I have -3 -5. Yes, again it is astigmatism. I have different powers. Similarly, if I take another example, I have +3 and -5. This is also astigmatism. One is plus, one is minus, and I have different power. So that means either I have different signs, or if I have the different power, or if I have the same power but with opposite sign. So I can have -3 and +3. So I have same power but opposite sign. So that means ultimately it is different. So then also it is considered to be astigmatism. But if I say that a person has +2 here and +2 here, it is not astigmatism. Or if I say the person has +3 here and +3 here, it is not astigmatism. But if I say a person has, okay, if a person has 0 power here and -3 here, then it is astigmatism. Okay, don't say that if one of the meridians is emmetropic, then it is not astigmatism. In either case the power is different now. If I say that this meridian is having 0 power, that means this meridian is having emmetropia, while another meridian has a -3. So that means this is having the myopia. So in one meridian the person is having emmetropic power, in another meridian he is having myopic power, so it is different. So again astigmatism. So this is very important, that even if one of the meridians are emmetropic, then also it is considered to be astigmatism. So one thing which is clear, what is astigmatism, right? Now we will try to understand what is actually regular and irregular astigmatism. One is called as regular astigmatism and one is called as irregular astigmatism. So first try to concentrate what is regular. If you understand what is regular, you will understand irregular itself. So in regular, I should have two meridians. Suppose I name them as M1 and M2. So I should have at least two meridians in which I am having the different power, M1 and M2. Now one of them will be horizontal and one of them is vertical, and third is that they should be perpendicular to each other. Now what they are trying to say, when I have a difference of power in at least two principal meridians, suppose I name them as M1 and M2, they should be having an angle of 90 degree. And third is, not only they are at an angle of 90 degree, they are perpendicular. One of them should be horizontal and one of them should be vertical. You will say that if they are at 90 degree, they have to be horizontal and vertical. No, it is not. For example, if I show you something like this. Suppose you have this. Now here I have got two meridians, M1 and M2. Both are perpendicular to each other also. Angle is 90 degree, but none of them is horizontal or vertical. So this is not a regular astigmatism. Then this will be a irregular kind of astigmatism. So if I am talking about a regular astigmatism, I should have two meridians, M1 and M2. Both should be perpendicular to each other at an angle of 90 degree, and one of them should be horizontal and another should be vertical. When I have met all these three criteria, I will say it is regular astigmatism. Alright. Now, once you are clear what is regular astigmatism, now we will try to understand what is with the rule astigmatism and what is against the rule astigmatism. Now, when I am saying that it is a regular astigmatism, I have got two meridia which are perpendicular to each other and one of them is horizontal and another is vertical. Obviously, one of them will be more curved than the other. So, power will be either more in the vertical meridian or it will be more in the horizontal, because it could not be same in astigmatism. That is the very basic. So, if it is not same, one of the meridians will be having more power. So, if I am having more power in the vertical, then it is called as with the rule astigmatism. But if I am having more power in horizontal meridian, then this is called as against the rule astigmatism. For example, if I am saying that a patient comes to you having -3 here and -5 here, then how will I make out that whether it is with the rule or it is against the rule? So try to see, this is your horizontal meridian and this is your vertical meridian. Now which power is more? -5 is obviously more than -3. So horizontal is more than vertical. So I will say that this is against the rule astigmatism, right? But what if I give you +3 and +5? What if I give you +3 and +5? Now don't jump over the against the rule, because +5 is not more than the +3. It is not more. It is not more. Why? Now always remember that if I am talking in terms of the power, then you have to remember certain things, that a minus power is always more than the zero power and a zero power is always more than the plus power. Always you have to remember this. Now what does this mean? Minus power means the person having the myopia. So myopic power is more than the emetropic power, and emetropic power is more than the hypermetropic power. Now why I am saying this? Just don't cram it. Just don't cram it on the basis that I have said. This should be rationalized. Now why I am saying? Because a person who is having myopia will have the rays which are focused in front of the retina. This is your myopia. The person who is having emetropia will have focus of the rays just on the retina, and the person who has hypermetropia will have the focus of the rays behind the retina. This is your hypermetropia. So suppose I say that this is the retina. So that means the patient who has myopia has more power. That is why the rays are focused in front of retina, while emmetropic have just the enough power to focuses on the retina, but the hypermetropia lags behind. He has less power, and that is why it is focusing much beyond the retina. So now you can remember M for myopia and M for more. M for myopia, M for more. So you can remember more the myopia. More the myopia, more the power. More is the myopia, more is the power, and lesser the hypermetropia. Lesser the hypermetropia, more is the power. So that means that -5 will be more than -3 because it is myopia, but +3 will be more than the +5. +5 power will be lesser than the +3 because as the hypermetropia increase, power will go on decreasing. So if you come back here, what is the answer here? Here the +3 power is more than the +5 power. So that means vertical is more than horizontal. So this is with the rule astigmatism. Are you very clear with this? So you have come up to the astigmatism. You have come up to know what is with the rule and against the rule. Now coming to the next important thing, and that is, what is simple astigmatism, compound astigmatism, and the mixed astigmatism. Now we will try to understand what is simple astigmatism, what is compound astigmatism, and what is mixed astigmatism. See, simple means it is simple. One meridian is emmetropic. If one of the meridian is emmetropic, life becomes simple. You have to give the correction in only one meridian, and that is why it is called as simple astigmatism. So if in the question any of the options is giving you one meridian as 0 power, that means it is a simple astigmatism. So one of the meridian will be focused just on the retina. One of the meridian will be focused just on the retina, and another meridian. Now if I talk about the other meridian, so this other meridian can be minus also, or it can be plus also. One will be plain because one meridian is having emmetropia, so one meridian is just having plain glasses, while the another meridian can be minus or plus. Minus if he is having the myopia, and another meridian will be plus if he is having the hypermetropia. So look at the other meridian. If the other meridian is focusing in front of the retina, then this will be myopic. Then I will say that this is simple myopic astigmatism. While if the other meridian is focusing behind the retina, then it is called as plus, that is hypermetropia. Then this will become simple hypermetropic astigmatism. So always start from the right hand side. First see whether or not it is astigmatism. If you are having same power, it is not astigmatism. Don't go for myopia, simple, compound, anything. But if it is astigmatism, then you have to see whether it is simple or not. For the simple, one of the meridians should be focused on the retina. So this is giving you emmetropia or the 0 power. Now once you have seen that one of the meridian is giving 0 power, it is emmetropic, then this becomes simple, right? So simple astigmatism. Then you have to see the other meridian is minus or plus. So if it is minus, it is simple myopic astigmatism, and if it is plus, it is simple hypermetropic astigmatism. Is that very clear? What is simple myopic astigmatism and what is simple hypermetropic astigmatism? Now we come to another one that is called as compound astigmatism. Compound. Compound means two. You cannot have compound with just one thing. So compound means two. So if I have both meridians having power. So power in both the meridians. Now if you have same power in both the meridians, obviously that will not be astigmatism. You have power in both the meridians, but they should be different first of all. Second thing, no meridian is emetropic. So if no meridian is emetropic, you are not having zero power in any of the meridians and you are having different power in both the meridians, then this is compound. So compound astigmatism may, another important thing is signs should be same. You should have the same signs in both the meridians. Because if you have different signs in both the meridians, then it will go to the category of mixed astigmatism. So either you have both minus or you have both plus. This is very important. Either you have both minus or you have both plus. Like for example, if I have both minus, so obviously number have to be different, because otherwise it will not be astigmatism. Suppose I say -2 and -3. Then this is compound astigmatism. If I have +2 and +3, this is also compound astigmatism, because you have none of the meridians which is emetropic, you are having different power with the same signs. So if both of them are negative, then I will say that this is compound, myopic astigmatism. While if both of them are plus, then I will say this is compound hypermetropic. Compound hypermetropic astigmatism, right? So if you look at the schematic diagram, suppose this is the retina. So if I have compound myopic, both of them will be focusing in front of the retina. So one is focusing like this suppose, and another is focusing like this. So both of them are compound myopic astigmatism, because both of them are focusing in front of the retina. On the other hand, if I have both of them focusing behind the retina, one is focusing here and another is focusing here. So both of them are focusing, they have got same signs but the amount is different. So this will be called as compound myopic astigmatism, and this is compound hypermetropic astigmatism. So now you know what is astigmatism, what is regular astigmatism, what is irregular astigmatism, what is with the rule, against the rule, what is simple and what is compound. Now coming to what you called as mixed astigmatism. Mixed astigmatism, as the name is telling you, is mixed. One meridian is minus and one meridian is plus. So if the person is showing myopia in one meridian and hypermetropia in another meridian, suppose he is having -1 in one and the +2 in another. So one meridian is minus, one meridian is plus. This is called as mixed astigmatism. So now we have covered up all the basic things about this astigmatism. Now another important thing is that when you give the cylindrical correction, always remember that the power acts at perpendicular plane. Whatever is the power of the cylindrical correction that you are giving, the power will always act at a perpendicular plane. So if you give at 90 degree, it will act at 180 degree and vice versa. This is a very important point, and when you solve the retinoscopy related questions, this will otherwise give you a barrier. in coming to the right answer if you do not know this. This is the property of the cylinders, that the power of the cylinders will always act at a perpendicular plane. Now with this basic knowledge, let's see the question given. Now the question was, which of the following is an example of compound myopic against the rule astigmatism? So we'll try to solve them one by one and see what is the answer. So let's take up the option number 1, -2 diopter spherical with -2 diopter cylinder at 180 degree. So how to solve this? First option is, they are saying that we have -2 diopter spherical with -2 diopter cylinder at the axis was 180 degree. The axis is 180 degree. So let's first convert this into retinoscopic finding. We have made something like this. Now -2 diopter is a spherical amount, so this will be acting in both the meridians, -2 here and -2 here also, while another -2, which is cylinder, is given at 180 degree. And you know that the power of the cylinder will always act at a perpendicular plane. So if you are giving at 180, it will act at vertical plane 90. So I will add -2 here. So what is the final amount you are getting? You are getting -4 here and -2 here. Now first see whether or not it is astigmatism. You are getting -2 here and you are getting -4 here. So always start asking yourself whether or not it is astigmatism. You have got different powers. So yes, this is astigmatism. So right, we have astigmatism. What type of astigmatism? Simple, compound or mixed? None of the meridians is emmetropic, so it is not the simple astigmatism. You have got different power in both the meridians with the same sign, so it is not the mixed astigmatism. So what kind of astigmatism? This is your compound astigmatism. So second answer is compound astigmatism. Number 3, myopic or hypermetropic. So you are having minus signs in both sides. So it is actually myopic astigmatism. So we have got that it is a case of compound myopic astigmatism. Now this compound myopic astigmatism, you have to find out whether it is with the rule or against the rule. So what I told you, that minus power is more than 0 power and this is more than plus power. Plus you also know more the myopia, more is the power. So that means -4 will be having more power than -2 and -4 is present in the vertical stream. So that means vertical is more than horizontal. So this will be what? With the rule astigmatism. So now you have come up that it is compound myopic astigmatism which is with the rule. So this is not the answer because you have to find out compound myopic astigmatism which is against the rule. So this is not the answer. Let's see the option number B now. The option number B says -2 diopter spherical with -1 and now they are giving at 90 degree. Now they are giving at 90 degree. So let's try to solve this. So option number B says -2 diopter spherical with -1 diopter cylinder which is given at 90 degree. So how to convert this into retinoscopic finding? We will write spherical correction in both the meridians. So -2 here also and -2 here also. While the cylinder is given at perpendicular plane. Now when you are giving at 90, this will act at horizontal plane right here. So -1 will be added in the horizontal plane, by which you are getting -2 and -3 here. Now see whether this is astigmatism or not. This is -2 and this is -3. So you have different powers. when we have the different powers, it is the astigmatism. None of the meridian is emmetropic, so this is actually not a simple astigmatism. Both the signs are minus, so it is not a mixed astigmatism. So what is left? It is the compound astigmatism. You have different power with the same sign. So this is a compound astigmatism and both of them are minus. So this is actually a myopic astigmatism. Simple. It is not a simple astigmatism, it is a compound astigmatism and it is a myopic astigmatism, compound myopic astigmatism. Now look at the powers. More the myopia, more is the power. -3 will be more than -2. So this will be, that means horizontal is more than vertical here. So when horizontal is more than the vertical, I can say that this is against the rule astigmatism. So that means this is your answer. What they asked for? They actually asked for compound myopic. They asked for compound myopic against the rule astigmatism. So that means this is your compound myopic against the rule astigmatism. So your answer is here. But let us see the other options also. Your other options are, you have got +2 diopter spherical. So +2 diopter spherical, +2 here also, and you have +2 here also, and -2 cylinder is given at 90. So when you are giving at 90 vertical plane, this will act as horizontal plane. So when they are acting at horizontal plane, it will be acting here. So what will happen? This +2 will cancel with this -2 and finally you will be getting +2 here and 0 here. Now because one of the meridians is 0, this will become simple astigmatism. The sign is plus, so this will become hypermetropic astigmatism. And obviously this is astigmatism because one power is 0 and one meridian is plus, right? So 1 is 0, that means it is a simple astigmatism. You have other one that is plus sign, that means it is hypermetropic. Now can you tell me, is it with the rule or against the rule? Now see, minus power is more than the 0 power and 0 power is more than the plus power. So 0 power is more than plus power. Can you see here? That means the horizontal meridian is more than the vertical meridian. So very conveniently I can say that this is against the rule astigmatism. Alright. Now coming to the option number D, -2 diopter cylinder at 90. Is it astigmatism? You people must have started calculating, but use your common sense. This is a cylindrical correction, so obviously this has to be astigmatism. They are giving a cylindrical correction only in one day plane. So how to solve this? They are saying that we have -2 diopter cylinder at 90 degree. So again put it at retinoscopic findings. When you are giving at 90, this will be acting at 180. So -2 here. So I do not have any other power. So other becomes 0. So that means what? This becomes simple astigmatism. This is minus. So this is becomes myopic astigmatism, right? With the rule or against the rule. Now minus power is more than 0 power. So this is horizontal more than vertical. So this is simple myopic against the rule astigmatism. But you had to told what? Compound myopic against the rule. So your compound myopic against the rule astigmatism is -2 diopter spherical with -1 diopter cylinder at 90 degree. I hope you have got the concept of what is astigmatism, what is regular astigmatism, what is simple, compound and mixed astigmatism, and what is actually more in terms of the power, how you have to say whether it is with the rule or against the rule, and point number 5, how you calculate the retinoscopic findings, how you can convert this into retinoscopic findings. Never attempt the question directly. You will always have to convert it into retinoscopic findings and then tell your answer whether it is astigmatism or not, whether it is regular, irregular, simple compound or mixed, with the rule or against the rule, or any other thing which they ask. Thank you and happy ophthalmology.